So the genetics of Parkinson's disease are very challenging. Basically, Parkinson's affects 1 in 1,000 people. But interestingly, if you go to a support group where people have got Parkinson's and speak to them, about 1 in 10 people who have Parkinson's will have a family history. So there's clearly something in the genes that makes you more likely to get the disease. Now, scientists over the last 20 years have identified a number of genes that can cause Parkinson's, and most of those diseases look a bit different to the patients that I see generally in the clinic. They're often younger, so under the age of 30, and that means pretty young for Parkinson's, and they have a very strong family history, so more than one person in the family. As opposed to sporadic Parkinson's, so mostly people who are older, in their 60s and above, who may have somebody in the family who've got Parkinson's, maybe a cousin, for example, here or there. The specific genes that are out there can sometimes look a bit like that, so they are a different type of gene, not so strong that every generation is affected, but it every now and again crops up. And interestingly, the most striking gene that's been reported in Parkinson's is a gene that is called GBA for short, glucocerebrosidase, and what it does is it clears junk out of the cells. And interestingly, about 5% of patients seem to carry this gene, and only one copy. In fact, if you have 2 copies of that gene, you get a completely different disease called Gaucher's disease. So what's the point of all of this information, I hear you asking? Well, do I get a gene test for my Parkinson's? The answer is probably not, because most of the time we won't identify a gene. However, where it is important is the idea of, well, genes must do something. They make proteins, or they do something that's important in cells. So when we find a gene that causes or is associated with Parkinson's, what we're really doing is getting a clue to what's causing Parkinson's. And that's only half the story, because of course if we understand what it is that's damaging cells and causing cell death, that's when we can start targeting therapies and aiming to change that disease course and perhaps even cure diseases.